Alright, so let's actually talk about fractions. The first thing that I want to describe with fractions is that we can rewrite fractions without changing their number. We can change what they look like. So we call these equivalent fractions. And so for instance, if we had something like 2 over 10, if that's the fraction we're talking about, and I say I want it to have a denominator of 40, then the denominator is the number on the bottom part of the fraction, by the way. One of the things I can do with fractions is I can take and I can multiply both the top and the bottom of the fraction by whatever number I'd like, and it won't change the value of that fraction. So if I want it to be something over 40, then I just ask myself, what do I need to multiply the bottom of this fraction by to make it into a 40? Well, I would want to multiply by 4. But I can't do that to just the bottom. I have to do it to the top as well. And so you can see I multiply both the bottom and the top of this fraction by 4 to get up to 8 over 40. And these two numbers are equal. 2 over 10 and 8 over 40 are the same thing. You can actually verify, if you're wanting to check your work, you could do this by converting them both to decimals, just plugging them into the calculator. You can see 8 divided by 40, and 2 divided by 20, and 8 divided by 40 both give a decimal representation of 0.2. So that's one way to kind of see that those are the same number. All right, how about if we wanted it to have a denominator of 5? Well, just like we can take and multiply both the top and the bottom by the same thing, we can actually choose to divide both the top and the bottom by the same thing. So if I want it to be a 5 down below, I could choose to divide both the top and the bottom by 2, giving me 1 over 5. Now, this is not usually the way, at least when I'm writing these, it's not usually the way that I tend to write it. Usually how I write it is I'll do 2 divided by 10, and what I'll do is I'll go ahead and cross off this 2 and leave a 1, cross off the 10 and leave a 5. Now what I'm doing here is I'm kind of thinking of, well, actually kind of, you can get to it using the prime factorization of these two numbers. 2, of course, is prime. 10 is 2 times 5. You can see that I have a common factor. I have a 2 both up top and down below. And when I'm dividing both the top and the bottom of this fraction by 2, this is the same thing as just getting rid of that factor of 2. And you can see crossing out everything up top, well, I have to have a 1 left behind up there. I have the 5 left behind down below. This is, when you see people crossing stuff off, that's kind of what they're doing. They're dividing both the top and the bottom by numbers. They're just doing it in such a way, that's kind of a shorthand way of trying to show it. It can look a little jumbled, though. It can be hard to read what's going on. So, lowest terms. A fraction is in lowest terms when there are no common factors between the numerator and the denominator. So when you look at something like 16 over 12, I'll do two different ways of putting this into its lowest terms. The first way is kind of the just going forward with it without really thinking ahead. And this would be noticing that both those numbers are even and saying, well, I can divide both those numbers by 2 since they're both even. We get 8 over 6. And those are still both even, so I can still divide both of those numbers by 2. We get 4 over 3. At this point, you could check them again and see if there's anything else you could divide both the top and the bottom by. Of course, 3 is prime. 3 is not a factor of 4, so you can kind of tell that way that there's nothing else. An alternative way, I suppose you could use the prime factorization of each of these two numbers. 16 is 2 times 2 times 2 times 2, and 12 is 2 times 2 times 3. And so by using the prime factorization, you could say, well, I'm just going to cancel out factors. Again, this is the same thing. Doing what I just did right there is the exact same thing as what I did over here. It's canceling out a factor of 2 is dividing both the top and the bottom by 2. Then I could do it again, cancel out those, and you can see there's nothing else that's in common. And we get a 4 and a 3. Of course, we get the same number here. The nice thing about doing it with the prime factorization way is, well, you can essentially do all of your cancellation in one step, and you're not going to have to worry about, oh, did I cancel everything? So this is, I don't know. It depends on circumstances. You'll see me doing it both ways. I'll do it both ways, most likely. All right. Notice also, I should point out, just realized I did this on purpose. Notice that the top part of the fraction here is bigger than the bottom. This is not a problem. This actually has nothing to do with the fraction being in lowest terms. A lot of times I find people, when the instruction is to put a number in lowest terms, they want to convert it to a mixed number. Mixed numbers are not fractions. Let me write that down just to emphasize this. Mixed numbers are not fractions. When your instructions tell you to give a number as a fraction, if you give it as a mixed number, you will be marked incorrect because you gave the number in the wrong form. Now, that said, this is a particular type of fraction. This is called an improper fraction, and it can be converted to a mixed number, but that's kind of not really the point, you know. That doesn't really have anything to do with it being in lowest terms. It being in lowest terms is all about canceling any common factors between the top and the bottom to make the numbers smaller. Essentially, that's the main reason to do that. All right, if we have 25 over 96, and we're trying to put this in lowest terms, then you might sit here and look at it for a little while and say, well, I can't think of anything. Maybe it's already in lowest terms, but I'm not sure. Well, this would be another case where it might be to your advantage to at least think about the prime factorization of, you know, you don't even necessarily have to have the prime factorization of 96. But 25, getting the prime factorization here is pretty easy. It's just 5 times 5. I know that if there's anything that will be able to cancel from top and bottom, it would have to be a 5, because that's the only factor that's present in 25. And I know because of my divisibility tests that 5 is not a factor of 96. So actually, pretty quickly I can say without any doubt that 25 over 96 is in lowest terms. And again, that's because the only factors that could be canceled out here, the only ones that could be in common, would have to be 5s due to what the top is. But 5 is not a factor on the bottom. Therefore, there are no common factors.